Okay. All right. So let's jump in. Our formulae for analytical geometry. The first formula is our distance formula. So that's this one over here. Okay, so that helps us to calculate the distance or the length of a diagonal line. Okay, you don't need to use distance formula, grade 11s and grade 12s, when they ask you to calculate the length of a horizontal line or a vertical line. Okay, so when they ask you to calculate the length of a vertical line, you're going to say the y at the top minus the y at the bottom. For a horizontal line, you're going to use the x to the right minus the x to the left. Distance formula is only for lines that are diagonal. Okay. The next one is midpoint formula. The other thing that we need to be able to do with midpoint formula is this. Okay, so in other words, we have the x coordinate at the one end plus the x coordinate at the other end divided by 2 gives us the x coordinate at the midpoint. So we've got to be able to set it out like that in order to be able to work backwards. And it's the same with our y coordinates. The y coordinate at the one end plus the y coordinate at the other end divided by 2 gives us the y coordinate at the midpoint. So don't forget about setting it out like that as well, in case they give you the midpoint and they want you to calculate either an x or y coordinate at the end that's missing. Okay. Then this formula over here, we're all very familiar with this by now. That is the equation of a straight line. With m being our gradient and c being our y-intercept. This is another way that we can calculate the gradient of a straight line. Calculate the equation of a straight line. And then here what we would end up doing is subbing in a point in our gradient and then multiplying it out. I never ever work with this formula. I know some teachers that do. Personally, I never ever use it. Maybe your teacher at school uses it. I don't think it's necessary. I always use the one on the left, but it is on our formula sheet. Next one is gradient. Okay, so y2 minus y1 over x2 minus x1. Something to be careful of when it comes to gradient formula. If you are subbing into gradient formula and you, by accident, put the change in x over the change in y, you will not get any marks at all. Okay, so you've got to make sure that you sub correctly into your formulae. Okay, because if you put the change in y over the change in x over the change in y, you won't even get any substitution marks. Okay, so be very careful with that when using gradient formula. And then the last formula for our purposes today is going to be this one over here. So tan theta equals m. And by the letter m here, they mean gradient. Okay, so tan theta equals m allows us to calculate the size of an angle if we know the gradient of the line. And if we knew the angle of inclination of a line, it would also allow us to calculate gradient. Okay, so that formula there is also important for us. Matrix, you'll see there is no equation of a circle. Obviously, the grade 11s haven't done that. So our focus here is specifically on the grade 11 work. Okay, all right, so let's jump in and go and have a look at the first question that I shared with you. Now, I don't know whether you were able to work through this and get some answers, but I thought that I could work through it with you and show you, especially when it gets down to questions like 3.5, the correct way of setting that out. Is that okay with everybody? Are we're all happy with that? We'll work through it together and you can mark what you've done and I can show you how it's marked and where you would get marks, blah, 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 blah. Okay, all right. And please, if there's anything that I've said that isn't clear or you want to ask, put your hand up. You can ask me, you can ask Yolanda, it really doesn't matter. Okay, all right. So very easy when they ask us to calculate the length of line PQ, we can see that PQ is a diagonal line, so we're going to use distance formula. There is going to be 1 mark for subbing in. Okay, so distance of PQ, we can set it out like that. and we can go and sub in. Okay, so our change in our x's. So I'm going to start with the x's, 1 minus 3 squared, and then our change in our y's. So that would be 6 minus 0 squared. Okay, and then we can pop that into our calculators, and we should all be getting 2 root 10. Are you guys getting that as an answer to get 2 root 10? Just double check.
Looks majority of us are getting that.
Okay,
Yes, on the
good stuff.
chat. Yes,
And they
yes,
said to
yes.
us, lovely, lovely, lovely. They said to us, leave it in simplest third form. Okay, so that would be exactly as it is over there. Let's move that down a little bit, then we can see the questions and our diagram. Okay, so there would be a mark for subbing in. Okay, and then a mark on the answer. That's why it's out of 2. Okay, next thing they want us to do is calculate the coordinates of T, the midpoint of QR. So that's also an easy level 2 question. So subbing into midpoint formula. All right, so of QR, so that would be 3 plus 12 over 2 for the x coordinate at t, and 0 plus 3 over 2 for the, oh, sorry, I should put t there because we're actually calculating the coordinates of t. And that means the coordinates at t are going to end up being 15 over 2 and 3 over 2. All right, so again, 2 marks. Level 2 question, 1 mark for subbing in, 1 mark for the answer. Okay, and then the next thing, nice, simple, lovely questions to get us started, get our brain working. Calculate gradient. So here, the gradient of QR or RQ, it really doesn't matter. Okay, so we've got 3 minus 0 up at the top over 12 minus 3 at the bottom, and that's going to give us a gradient of 3 over 9, which is 1 over 3. Let's just move down a little bit and put that over there. Okay, so again, be careful, right? Especially with gradient, if you put change of x at the top and change of y at the bottom, they are likely to mark you down on that. Okay, so 1 mark for subbing in, 1 mark for the answer. So like with Euclidean geometry, when we answer questions in the beginning on analytical geometry, it helps us to build up a picture or a set of information about the diagram that we are working with, that more than likely we are going to use later on. Okay, so it's just knowing what to use where. Okay, you got the same answers as me, Lebogang? Yes, 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 everybody's all right. There we go. Mbasa, I'd like to think that if you ended up with an equivalent fraction and you didn't simplify it, that you would still get the marks. Because at the end of the day, you're not in grade 8 anymore. They're not testing whether you can simplify fractions. So I'd like to say yes. Whether if it's an internal paper that you're writing, maybe your teachers will decide that they're going to penalize people for that. But I should think that in an exam, if you've got an equivalent fraction and you haven't simplified, they shouldn't mark you down. Okay, but to be on the safe side, if you do simplify it, then you can't lose any marks. Okay. But yeah, I think that penalizing people for something like that, that's just my own personal opinion, is silly because, it's an equivalent fraction. If it wasn't an equivalent fraction, by all means. But yeah, just to be on the safe side. Okay. All right. What was the next thing that they wanted us to do? Okay, so they want us to calculate the size of theta. So when we go back and we look at the diagram, we can see that the gradient of the line, QR, it is a positive gradient. Angle theta is an acute angle. So here, calculating the angle of inclination really is quite simple. Do we know what to do when the gradient is negative? Right. So I think that that's something that I should discuss here with you guys, in addition to doing this question as well. Okay, so calculating the size of theta, we have to use the formula tan theta equals m. Okay, so in this case, we have already got the gradient of line QR. Okay, so I can go straight away and I can go and sub that in over here and say that it's equal to 1/3. All right, so theta, when I put this into my calculator is programmed to give me an acute angle as an answer. Okay, but I know that from trigonometry, I could have other answers. Okay, but it's an acute angle, so we know that it's in the first quadrant. So shift tan, pop in your ratio, and you should be getting an angle for theta of 18,43 degrees. Exactly. Well done. Perfect. Okay, so again, it's a case of subbing in and then getting the correct answer. So what I want to do now, before I move on, all right, is I just want to talk a little bit about what happens when the gradient of the line, oh, that is a very skew, beg your pardon. That is a very skew. Let's rather do this. Okay, it's better. Okay, so I'm going to make up some coordinates here just for sake of argument. So we're in the second quadrant here. So let's say -2 and 3 are the coordinates at that point. And let's say over here, our coordinates are 4 and -1, right? So now that would be your angle of inclination. All right, so we could see in the diagram that we were given, our angle theta was acute. Here, theta is not acute, it's obtuse. All right, so the correct way to set this out and to calculate this is as follows. First of all, we need the gradient of the line. So if we call this point over here A and that one over there B, we need the gradient of line AB. And you know what's also helpful in Euclidean geometry is that when you are calculating the length of a line or the midpoint of something, is to label it like this so that the person marking your work knows what it is that you're trying to calculate. Okay, it just makes life easier for them to understand what you're writing, and that in turn is good for you. Okay, so if you had a look over here on the left-hand side, when I calculated the length of PQ, I wrote there DPQ, and I correctly labeled T, my midpoint. And then when I was calculating the gradient of line QR or RQ, I labeled that that was what it was that I was trying to do. Okay, so the little things like that can help, especially when the questions become a little bit more complicated, as they so often do. No problem, Teddy. Welcome. We are busy working out the gradient of line AB because we're going to calculate theta, that angle of inclination. Okay, so we would come along and we would say 3 minus -1. And we could write 3 plus 1 if we wanted to. And then over here, we've got -2 minus 4. Okay, so the gradient of this line is going to end up being 4 over -6. Or if I simplified that, it would end up being -2 over 3. So now, when I want to calculate my angle of inclination, I would first write down, let's just scooch over a little bit, that tan theta is equal to the gradient, which in this case is -2/3. What a lot of students do here is that the next thing that they end up writing is theta, and then they'll write, and please don't write this, okay? Just listen very carefully to what it is that I'm saying, because this is wrong, and I'm going to rub it out. I just want to show you the mistake that gets made, okay? So then, so let me just go back and explain from this step over here. So we've worked out the gradient of line AB. We've said tan theta is equal to -2/3. And then we have written down incorrectly, that's why I've underlined it, that theta is equal to 33,69. Okay, theta is not an acute angle. Theta is an obtuse angle. So if we write that theta equals 33,69, it's incorrect. Okay, and we will be penalized for that. So then what some students do is they come along and then they say, okay, so theta is equal to 180 minus 33,69. And then they write down the correct answer after this, which would be 146,31 for argument's sake. Okay, so this is one of the places where we end up writing something and we end up being penalized for our answer. Something like this would be out of 3 marks, because there would be a mark for calculating the gradient, a mark for probably using tan theta equals whatever that is, and then getting your answer over here. So you would end up, or potentially what they could do is they could give you a mark on calculating the PAA or the reference angle and not give you that mark over here. So you could end up losing 1 out of 3, or maybe even 2 out of 3 marks, depending on the situation. Okay. First of all, you cannot have 2 different answers for theta in this situation. There's only one solution for theta. So to first write what I have over here and then to then write that, even if you've got your second answer correct, you're going to end up losing it anyway because of what's been written over here. Okay. So do not write that it is theta once you have put your ratio in. Now, other people do things so this over here is incorrect. That's why I was saying to you guys, do not write this down. Okay, do not write this down. So I'm going to rub it out and I'm going to show you something else that students do here that is allowed, but it's not the way I teach it. But just because it's not the way I teach it doesn't mean that it's wrong. Okay, so some teachers, okay, and it really depends on what you've learned at school. Some teachers teach you to calculate the angle using the negative. So what ends up happening is now we go shift tan on our calculators and we put in -2/3. And can you see it gives us a negative angle? The same answer, but a negative angle. Can you see that? Are you getting negative 33,69 on your calculator if you're putting in -2/3 as your yes? Okay. So it's okay to do that's not the way I teach it. It's okay to do that, but then you also cannot write theta equals negative 33,69 because this is also wrong. Okay, what you've actually calculated when you do this is this angle over here. So if you understand the Cartesian plane, you understand trig. When we go in that direction, angles are negative. So clockwise, angles are negative. That's why if you use the -2/3, it's going to give you a negative angle. Okay, so that would also be incorrect. Sometimes we see this happening as well. Okay, so don't make the mistake of doing that either. What you are actually supposed to do here is this, is that you're supposed to calculate a reference angle. You know, when you're solving for or doing a trig equation, or you're doing a general solution, and you have to find a reference angle or a key angle, you're supposed to do the same thing over here. You're supposed to find a reference angle or a key angle. I like to call it, instead of calling it a key angle or a reference angle, I like to call it a PAA. And PAA stands for a positive acute angle. Okay, so I like to use those words to remind us that first of all, it must be positive, and second of all, it's got to be acute. Right. So what we would do now is we would write down our PAA. We do not use the negative to calculate the PAA. So we know our PAA is 33,69, and then we can write, therefore, theta would be equal to 180 minus our PAA. And that would give us our 146,31, I think it was, yes. Okay. Now, what you may also have found, yeah, sorry, Cassandra, go for it. I understand there might be some questions here. You're welcome to unmute and speak.
Hey, ma'am.
Hello.
So, quick question. When we write down theta and we put in a negative angle, can we not just go negative 33.69 plus 180?
You can.
Okay,
You're
thank you, ma'am.
allowed to do that. I was going to say that right now, but I'm glad you
Okay,
mentioned it. So
okay,
yes,
thank you, ma'am.
absolutely not a problem. Some teachers would teach that. Some teachers would teach you to do that. So they'll say theta equals, and then you've got your negative 33,69, and then, as you were saying, Cassandra, to that you have added, let's just scooch over a little bit here, you have added 180. Okay, but you have to write it that way. So you can't write theta equals negative 33.69. You have to say theta equals negative 33.69 plus 180. So if you do that, you're okay. All
Okay,
right,
thank you.
not a problem. So it's a reference angle, essentially. Was it Lesedi? Okay, so you can, if you can say RA, you can say key angle, you can say PAA. It's not a problem. Or you can do what Cassandra said, and you can set it out in the green. You're not going to get marked down for this, okay, for saying that it's a PAA. It is a PAA. All right, it's a reference angle in this case. All right, or a key angle. Okay, but it's not, what is important is that 33.69 or negative 33.69 is not theta. Okay, yes, Lesedi.
Hi, ma'am.
Hi, Lesedi.
Ma'am, I have a question. Can you say it's a positive acute angle, even though we express it as negative 33.69, and then we add the 180?
You see, what I would do is that if you are going to do what is here in orange, then I would say you would set it out exactly as I have done over here. Otherwise, if you've got tan theta equals minus 2/3, you could go straight to what is there in the green. Okay, and then you don't have to worry about stating that it's a PAA and that you're subtracting it. You could go straight to theta equals minus 33.69 plus 180. Okay, and then you don't even have to write that it's a PAA if you don't want to. Okay. Shantae, I hope I pronounced your name correctly. Would you like
Yes,
to ask something?
ma'am, in the case that we've calculated our gradient and it is positive, and we find the angle for theta, do we still need to do the, is it still considered a reference angle?
Yes and no, Shantae, because if you think about it, okay, if you think about like if you are working with a trig equation, right? And let's say we're working with sine theta. Okay, so I'm just going to scooch over here. Let's say we're working with sine theta. So if I said to you that sine theta was equal to 2/3, all right, when if I say to you solve for theta, you're going to have two solutions, aren't you? Okay, you're going to have one solution in the first quadrant where your solution is the same as your PAA or your reference angle. Does that make sense to you? And then you're going to have another solution in the second quadrant where you're going to have 180 minus your PAA or 180 minus your reference angle. It's exactly the same idea as this. Okay, so in other words, when your gradient is acute, like it was in this case over here, theta is your PAA. All right, so so it's not necessary for you to calculate that reference angle when the gradient is positive. You would only do that when your gradient was negative. Okay, so what I wanted to emphasize here, I hope that makes sense to you, Shantae.
Yes, thank you, ma'am.
No problem. Okay, so if you are calculating a reference angle first, say that it's a reference angle. Okay, otherwise you can do what's there in green. Just don't write that theta is 33.69 or that theta is negative 33.69 because it isn't. Okay. Yes, absolutely, Gugu. So we're doing what we're doing here in the orange or in the green because the gradient is negative. Okay, so that's just something else to be aware of when you are calculating the angle of inclination and the gradient is negative. Okay. All right. Now, another point that we need to discuss, something that's important, is when they say to us, show that PS is perpendicular to PQ. Now, I don't know about you guys at your school, but I know the boys that I teach, the first thing that they want to write down is that when I multiply the gradient of the one line with the gradient of another line, I get -1. Okay. And then they end up losing all the marks and they're never really sure as to why. Okay. So if you want to prove something, the word show means to prove. Okay, so we cannot write down what we are trying to prove as our opening statement. Okay, that's got to come at the end. That's what we're trying to show is true based on the calculations that we've done. So when they say show that PS is perpendicular to PQ, what they want from you is the gradient of PS, the gradient of PQ. Show that when you times those numbers together, you get -1. And that's why these lines are perpendicular. Okay, so you cannot start writing. The first thing is that the gradient of PS times the gradient of PQ equals -1. That's what you want to prove. Okay, so that's really important, especially in a question like this. It's a sort of thing where we see the sort of same mistakes made over and over and over again. Okay, so do we have any of this information? Do we have the gradient of PS? What do you guys think by looking at the diagram? Do we know what the gradient of PS is? Yes, we do, Cassandra. Okay, because QR and PS are parallel lines. Okay, so we know the gradient of PS. Do we have the gradient of PQ? That's right. Okay, so we would set this out as follows. Okay, so first of all, we would say that the gradient of PS equals 1/3. Okay, and that is because PS is parallel to QR. Okay, now we want to calculate the gradient of PQ. And again, can you see how if you tell the person marking your work, this is the gradient of PS, this is the gradient of PQ, then they can easily follow your argument and mark you correct for what it is that you are doing. Okay, calculating the gradient of PQ, we would say 6 minus 0 over 1 minus 3. Okay, so this is going to give us a gradient of -3. 6 divided by, sorry, -2. Hang on, have I done something wrong here? No, sorry, 1 minus 3 is -2. So 6 divided by -2 is -3. Okay, perfect. So now when we look at the numbers that we've got, now we can say, okay, a third times -3 is -1. That means that the gradient of line PS times the gradient of line PQ is -1. We have proved it. Okay, we didn't start out assuming that it was true. We've proved it. And therefore, PS is perpendicular to PQ. Okay, so that's the correct way in which, yes. Right, so if they ask you to prove that lines are perpendicular, you do it by showing that the product of their gradients is -1. Okay, so you've got to work with the gradient of PS and PQ separately. You cannot write this. So this bit over here does not get written first. Okay, this is what we are proving. Okay, so this is what we're proving. Okay, does not come first. Is everybody happy with that? Lovely. Okay, so let's just have a look where the marks would be allocated. This is out of 3. So there is going to be a mark for here. For it would be the third times the -3 equals -1, and your conclusion. Okay, so there, I think for that, and like, oh, no, hang on, that's too many. Hold on, sorry. So like so. Okay, good job. All right, well done, everyone. Okay, so let's get into the sort of slightly more interesting questions here. Question 3.6 tells us that AB is a straight line passing through vertex P of this trapezium, and it makes an angle of 45 degrees with PS. The angle of inclination of AB is theta. In 3.6.1, they ask us to show that beta is 63,43 degrees. Where do you think that's coming from? How do they get that beta is 63,43 degrees? Any ideas? Okay, but Lumelo, you don't have coordinates at A or B. So we don't know the gradient of line APB. Teddy, where do you think it comes from?
Ma'am, they said it's passing through P.
Mm-hmm.
So we've got the points of P, and we can use the x-intercepts.
Okay, but how are you going to get the x-intercept of
Oh
line
yes,
AB?
oh yes, oh
You see,
yes,
the
oh yes,
problem,
oh
the
yes.
problem here, Teddy, is that we don't have the coordinates at A, and we don't have the coordinates at B. So
At
we've
B.
only got, we've only got 1 point on that line.
Mm.
Okay. Indeed. Let's see what the others are saying on the chat. Okay, so Cassandra says exterior angles and exterior angle of triangle. Okay, but if we were going to do exterior angle of triangle, Cassandra, then we know what this is. We would need this angle over here. okay? Because this angle over here and beta actually would add up to that entire angle over there. So that's not going to help us in this case. Now you're starting to get a little bit closer, right? So this is an unusual question because often in analytical geometry, we're not required to do this. And in fact, we shouldn't ever really be constructing anything ever, okay? What they want you to see here, grade 11s and matrics, is this. If I draw a line, a horizontal line through P, and I'm going to move this down a little bit because I do realize it's a bit high where it is. Let's just move it down. If I drew a horizontal line through P like that, okay, this line that is horizontal would be parallel to the x-axis, wouldn't it? Which means that this angle over here would also be theta. Does that make sense to everybody? Okay, they would be corresponding angles essentially. Can everybody see that? So the theta down here and the theta up here would be corresponding angles. Okay. I think because, Cassandra, if it was out of a lot more, then you just end up losing a lot of marks for nothing. So I think they were trying to be kind by making it out of 2 rather than making it out of too many more marks. All right. So I think that's the idea. Okay. Because if something's worth if something's very difficult and it's worth a lot of marks, then you're going to lose out on a lot. Whereas here, you know, it's they don't want you to lose out on too much. Okay, so whoever said this question was actually trying to be kind, believe it or not. Okay, so we can see that theta is the sum of these two. So I think what we would need to do in a situation like this, all right, is indicate that we have drawn a horizontal line through P, and let's just put it over here, 3.6.1. 3.6.1, I've said horizontal constructed through P, parallel to x-axis. Therefore, beta would be equal to 45 plus 18,43. And that would give us 63,43 degrees. Okay. All right, so that's a bit of a strange question. That's not something that we see very often. And of course, what I haven't mentioned, I probably should go back to my answer and do that, is that this angle over here, the 45 plus theta, is going to correspond with angle beta over there as well. Okay. Yes, sure. There you go. So I've written that. Okay, so I think what would be important here is that we've said we've constructed this line through P and that we've shown that it comes from adding 45 and 18.43 together. As I say, a bit of an unusual question, but there we go. Now they ask us to determine the equation of AB. So in other words, AB we see as a straight line. I'll go back up to the picture. You can see AB is a straight line. Okay. So we know, oh, whoopsie daisy. Sorry, I didn't mean to do all of that. But anyway, let's just put it back. There we go. It was theta. So AB is a straight line. Okay, we now know what this angle beta is over here, that it is 63,43 degrees. When they want the equation of AB, they want it in the form y equals mx plus c. So does anybody have any ideas about how we could get the gradient? How are we going to get, yes, Teddy, what would you do?
It's in the p-values, ma'am.
The p-values. Okay, you will have to do that, but you need your gradient first because we
Oh.
don't have the y-intercept. So how are we going to get the gradient? There we go. So Cassandra's put it in the chat. Well done, Cassandra. You're quite right. Okay, but now you need to be careful. Again, there's more than one angle here. So I know that on our formula sheet, it says tan theta equals m. But in this case, it's not tan theta, it's tan beta. Okay, so tan beta is m. Okay, and then we need to write here, it is the tan of 63,43 degrees that gives us the gradient of this line. So now we can calculate that. So you're going to say tan 63.3, and the gradient of this line ends up being 2. Okay, so we're using tan beta equals m to get the gradient of AB because there's no other way to calculate it. We don't have any coordinates A or B that we can use. So the only thing that we can do to get the gradient is to go back to tan beta equals m. Now we can say that y equals 2x plus c, and we can sub in point P like you were saying, Teddy. The coordinates are 1 and 6. So 6 would be our y coordinate, 1 is our x coordinate, and we can work out the value of c. So c ends up being 4. Okay, so that means that, sorry, I've written all over the place here. It would be the line y equals 2x plus 4. Okay, because beta is not equal to 45, Msomi. Okay, beta is equal to 63.43. Caitlin, when you said the inverse, what do you mean? Sorry, there's a couple of questions here. Cassandra, I'll come back and answer. Okay, oh, I see what you mean, Caitlin. Okay, so now here, Caitlin, we're calculating a ratio. We're not calculating an angle. Okay, so there's a difference. All right, so let's just scooch over here because I think this is something that's worth discussing. Okay, if we go back to what we were saying earlier, Caitlin, where we've got sine theta equals 2 over 3. All right, if I want to know the size of theta, and let's say here theta is an angle between 0 and 90 for argument's sake, okay, just to keep things simple. Then on your calculator, you're going to go shift tan, shift sine, and put in the 2 over 3. Okay, because you need to tell your calculator that it's calculating an angle. But if you have got the tan of 63,43 degrees, you know the angle, you know what this is. So you're not going to go shift tan because when you put in the tan of 63.43, it's going to give you the ratio. This over here, this is your ratio. Over here, this is your ratio. Okay, so the idea is, all right, let's draw ourselves a sine graph because I think it's just easier to understand with the sine graph rather than with a tan graph. When you're saying sine theta equals 2 over 3, that 2 over 3 is an output. So you are saying what is the corresponding size of the angle, the x value, when y is equal to 2 over 3. Does that make sense to you? I hope that answers your question. pleasure. Right, so in this case, we knew the size of the angle. We were calculating the ratio or the value of y, in this case, our gradient. Okay, all right, so there we go. We've got 3 marks for that. There has to be a mark for calculating our gradient, subbing in that point, and then on our answer. Okay, cool beans. Let's go to the last question. Now, the matrics are used to this just because they've had an extra year of practice, but grade 11's question 3.7, it's the method of how we would answer a question like this is something that we see over and over and over and over and over and over again in maths, right? They want us to calculate the coordinates of S. So that means they want the X coordinate and they want the Y coordinate. Because they want us to calculate 2 different variables, what method do we have to use here in 3.7? What method? Because they want us to calculate an X and a Y. That's it, Teddy. That's it, Lumelo. Good. Okay, they want a simultaneous solution. Okay, so what happens 99.9% of the time with simultaneous solutions like this is we have, so to do a simultaneous solution, we need 2 equations, right? So a lot of the time, it's going to be a quadratic equation together with a linear equation, just like we do in paper 1. Remember when they ask us in question 1 to solve simultaneously, they give us 1 linear equation, 1 quadratic equation, we rearrange the linear, we sub it into the quadratic, and then we do our solution. It's a common theme that comes up over and over and over again. Okay, so in this case, they're telling us if PS equals 10, calculate the coordinates of S. They're giving us a vital clue here, right? What are they actually saying to us when they tell us that PS is equal to 10? How do they want us to use that information? Anyone got any ideas? What does this mean for us? What do they want us to do? There we go. Good. Good. So they want us to use the distance formula. That is 1 equation. All right. So they're dropping some major hints here. Absolutely. All right. So we would come along and we can go up and down to our diagram. It doesn't matter. What's this question 3.7? Okay. And we're going to write down our distance formula. Okay. So we know that distance is equal to, okay, and then here we've got our change in x's squared plus our change in y's squared, okay? We know the coordinates at P, it's 1 and 6. And we don't know the coordinates at S, that's what we're trying to calculate. We also know that the distance of PS is root 10. So when we sub in here, we would put in our root 10 for our distance. And underneath our root sign over here, we could go x minus 1 squared plus y minus 6 squared. And the next thing we would have to do is what? How would I get rid of those horrible roots? What would I do to both sides? Oratile? You're welcome to speak. Good, everybody in the chat. Okay, 100%. So everybody is saying I need to square it. Good. So you're going to end up with 10 equals x minus 1 squared plus y minus 6 squared. Okay, now I could continue further here, all right, but I'm working in terms of X and Y, all right, and that's not what I want, okay? So I need another equation that I'm going to sub in here. This equation, distance, is my quadratic. So I need a linear equation that I can sub in, either in terms of X or in terms of Y. Right? So this is my first equation. I need another equation. So I'm going to go back and I'm going to look at the information that I've got. Right? They want the coordinates at S. I know the length of this line. Do I know the gradient of this line? Do I know the gradient of PS? Let's just think about what we've got. Yes, we know that it's 1/3, okay? So this is an equation, isn't it? This formula over here is an equation, right? And it would be a linear equation because nothing's been squared in it, right? So I could use gradient, right? So again, I go back and I know, I'm just going to write it down here, that gradient is change in Y over change in X. So we all know that the gradient of PS was 1/3. Okay, so I can say Y minus 6 up at the top. And at the bottom, I can say X minus 1. What would I do to this green bit now? How would I get it so that I don't have a denominator anymore? What would be the correct thing to do mathematically here with algebra and solving equations? What could I do? There we go. There we go. Absolutely. A lot of you are saying different things, but all saying the same thing. Cross multiply. Absolutely. Multiply by the lowest common denominator. Absolutely. Cross multiply. Yes. Bokang, that would be the easiest thing for us to do. Okay. Would be to cross multiply. So remember, we cross multiply to solve equations. So I'm going to put brackets around that. We're going to cross multiply this way, and we're going to cross multiply that way. So we'd end up with X minus 1 is equal to 3 into Y minus 6. Absolutely. And now we would be distributing Teddy. Okay, so X minus 1 equals 3Y minus 18. Okay, it doesn't matter which variable you make the subject. You've got a 1 in front of your X. So I think it's a good idea to make X the subject of the formula. So you'd add 1 here, you've got to add 1 here, and you'd end up with 3Y minus 17. Can you see there you have created a linear equation from substituting into gradient formula? Okay, does that make sense to everybody? Are there any questions before I move on? Are we all happy about where this comes from? Okay, so remember, when we want to solve simultaneously, we need 2 equations, right? If they want us to solve simultaneously, we've either got to have 2 linear equations and solve simultaneously, or a linear and a quadratic. If we've got a quadratic that they've already given us, like distance formula, we need a linear that we can sub in. So we want to make one of the letters, either the X or the Y, the subject of the formula. Okay, so when we're dropping the 10 Ayanda, we're not dropping it, we've squared both sides. Okay, Lesedi, do you want to ask something? I'm just going to move this down in the meantime.
Ma'am,
Hi, Lesedi.
ma'am, can you quickly explain why we found ourselves using the gradient of PS?
Because if we want to make equations, all right, these are the formulae that we've got. Okay, so we can either use gradient is an equation, or the equation of a straight line. We don't have the midpoint over there, but we knew what the gradient of PS was. So I said, well, because this is a piece of information we could use, maybe gradient formula is one of the things that we could use. Okay, we could also, if we wanted to, in this case, we could have also used the equation of PS, which would be another way of doing it. Okay, I've just worked with gradient. Okay. All right. So now we're going to go and we're going to sub in. So where we see the x, we're going to write 3y minus 17. Okay, so now I'm subbing in, guys. I've got my 10 on the left. And in place of my x over here, I'm putting in 3y minus 17. And then I've got my minus 1 after that, and it's squared plus y minus 6 squared. Okay, so this ends up being quite a difficult thing to then end up, well, not that difficult, but then to end up multiplying out. Okay, so this is going to give me 3y minus 18 squared plus y minus 6 squared. Okay, so let's square out our brackets. Is everybody happy here if I just go straight to 9y squared minus, and then 18 times, this would be minus 108 y, and then that would be, is everybody happy with where I'm getting that from? I've squared the first binomial, and then I'm going to square the second one. Does that make sense to everybody? Okay. Okay, so Rosaria, I'm just multiplying 3y minus 18 with 3y minus 18. I'm doing FOIL. Okay, so what I'm getting here, what I've underlined in green, is what I would get from FOIL, Rosaria. Okay. Mesh, same story. Okay, so 3y minus 3y times 3y would be 9y squared. When I multiply 3y with minus 18, I would end up with minus 54y. 4 minus 54y plus 324. Okay, you see where it comes from now? Okay, cool. And I want to collect my like terms. I want to get it into standard form. So I'm going to make it equal to 0 on this side. I've got 9y squared plus y squared gives me 10y squared. I've got minus 108, take away another 12. So that gives me negative 120y. And then I've got 324 plus 36 minus 10. So that gives me 350 at the end. Okay, when I've put it into standard form. To make life easy for myself, I'm going to divide through by 10. And that should be easy for me to factorize now. Okay, so two numbers, when I multiply them to give me 35 would be 7 and 5. And if I use minus 7 minus 5, I'm going to get that minus 12 in the middle that I want. Okay, so now I have two solutions. Of course I do, because it's a quadratic that I'm solving. So either y is 5 or y is 7. So it can't be both. All right, in this situation. So now I need to go back and I need to go and have a look at what I've got. All right, would it be 5 or would it be 7? Looking at the diagram, how would you know which one to choose? at S? How would you know whether it was 5, whether y was 5, or whether y was 7? Looking at the picture. Anyone got any ideas? Exactly, Rosaria, by looking at the coordinates of P. So what is the y coordinate at P? Exactly, Kotwano. Yeah. Yes, Gugu. Exactly. The y value at P is 6. And S is above P. Okay, so it can't be 5, so it's 7. Yes, 100%. Okay, so it must be 7. Good. All right, so that's why we've got to go back, look at our diagram, and make a decision. Okay, so it's not 5 at SY equals 7. And now we can go and solve for X. So we've got X equals, remember we're using this equation over here, 3 times Y, and that would give us 21 minus 17, which gives us an answer of 4. So therefore, the coordinates at S are 4 and 7. Okay. Is that making sense to everybody? Are we all good? Good, Lumelo. Good, Mesh, Rosaria. Good, Oratile, Cassandra. So this was out of 5. Okay, so let's work backwards. We've got to have the, although, probably it would be there rather. Getting the 7, there would have to be a mark for getting this. There would have to be a mark for 1, 2, 1, 2, 3, 4. Maybe standard form over here. Okay, so this is one of those questions. There's a lot of working here. Okay, a lot of working here for 5 marks. Probably should have been out of more than 5. But maybe it's not a bad thing that it wasn't out of more, because then we just end up losing more if we can't do it. Okay. All right. So let's go on and have a look at the next question, right, which is this one over here. And this is nice because this has a link in this question 3.6, back to our Euclidean geometry. Okay. All right. And again, they're asking us the same sorts of things in the beginning: gradient, length of a line, etc., just to get us warmed up. Okay, so let's work those out quickly, and then we can move on to the more juicy stuff. Okay, so the length of PS, we should get and let's just check we're all getting the same answer here. Are you getting 3√5? Oh, good. Okay. All right. Then the next thing that they want us to do, good stuff. Nice. All right, everybody. Okay, then the next thing that they want us to do is the gradient of QS. Okay, so that's also easy. Remember y over x. So that gives us a gradient of 8. So as we saw before, a mark for subbing in, a mark for the answer. A mark for subbing in, a mark for the answer. Okay, then some more sort of similar stuff. Determine the equation of the line passing through P parallel to QS. Write down your answer in the form y equals ms plus c. Okay, so what I was naughty, I was actually naughty. I should have read the information first. So in the figure, we've got on the x-axis as such that PQRS is a parallelogram. Okay, so that's obviously an important piece of information for us over here because we know that those sides are parallel and we know that those sides are parallel. So we should always read the information first. Diagonal QS is drawn, thank you. And they've given us angles of inclination. Okay. So they want us to determine the equation of the line passing through P parallel to QS, fair enough. So that means that we are going to use the gradient of QS in order to be able to answer this question. All right, so we can say that the gradient would be 8 as well. So y would be equal to 8x plus c. It passes through point P. So now we need to sub in the coordinates of P, -1 and 4. So we've got 4 equals 8 times -1. And that means that C would be equal to 12. So it would be the line y equals 8x plus 12. Are you guys getting that as an answer? Cool. All right. Now they want the coordinates at R, and this is out of 3 marks. So again, this is something that I want to have a little bit of a discussion with you guys about. They're asking us in question 3.4 to calculate the coordinates at the 4th vertex of a parallelogram, okay? There are 2 ways that you can answer a question like this. The first way, so let me just make some notes here for you. Okay, so question 3.4, we are calculating the coordinates at the 4th vertex of a palm. And we've got the other 3 coordinates. So we've got the coordinates at P, Q, and S, and they just want the coordinates at R, okay? The first way that you can do this, grade 11s and grade 12s, is using midpoint formula. Okay. I know that the diagonal from P to R is not drawn, but and you don't have to draw one at all. I'm just going to draw one so that we can look at something. But what do you know about the diagonals of a parallelogram? What do they do to one another? They bisect each other, absolutely. Okay, so this point over here, I know that it's neither labeled nor given, all right? Let's give it a letter. Let's call it T. Okay, so T would be the midpoint of PR. Okay, and T is also the midpoint of SQ. Right? So what I could do is I could calculate the coordinates at T using the coordinates at S and Q. So I would say 2 plus 3 over 2, and then I'd say minus 2 plus 6 over 2. So that means the coordinates at T would be 5 over 2 and 2. Is everybody happy with that? So Kutwano, we can do it. It's not inspection, it's translation. And I am going to show you how to do that as well. Okay, so there are 2 ways. The first one is midpoint formula, and then I'm going to show you how to use translation. I like translation because I think it's quicker and easier, but I'm just giving you the option of both. Okay. So the coordinates at T are 5/2 and 2. Right. Now we can work backwards to R. So in other words, the x coordinate at R plus the x coordinate at P, which is -1, over 2 is going to be the x coordinate at T, which is 5/2. As far as the y coordinate at R is concerned, the y coordinate at R plus 4/2 is equal to the y coordinate at T, which is 2. Okay, so we've got x minus 1 equals 5, so x equals 6. And over here, we've got plus 4 equals 4, so y would be equal to 0. And that makes sense because they did tell us that R was on the x-axis. Okay, so over here they said to us R is on the x-axis, so it makes sense that we would get a y value of 0. Okay, so therefore the coordinates at R have to be 6 and 0. So that's the one way you can do it. The other method, which is what Kutwano was talking about, was to use translation. Okay, so translation would work as follows. Okay, so I could do 2 different types of translations from here. I could either go from P to Q, S to R, or I could go from P to S, Q to R. It doesn't matter. Okay, both are fine. So let's say I decide I want to go from P to Q. All right. So I would say this. I would say P maps onto Q according to the following translation. So in terms of X, I go from -1 at P to 3 at Q. How many units have I moved over to the right? If I've started at -1 and I'm now at 3, it means that I have gone 4 to the right. So I need to add 4 onto X. As far as Y is concerned, I've also gone up. I've gone from 4 to 6. So I've added 2. Therefore, S maps onto R by the same way. Now, the x coordinate at S is 2. So I can say 2 plus 4. I'm subbing in my x. And my y coordinate at S is -2. -2 plus 2. I'm subbing in that. So therefore, my coordinates at R would be 6 and 0. Okay. All right. So yes, that probably is the quickest, easiest way to do it. All right. Matrices is probably more familiar to you than it is to the grade 11s. That being said, this is something that we do see for the first time in grade 10, but let's be honest, grade 10 is never the best year. So there we go. Is everybody happy with that? 3.4. Okay. All right, lovely. So again, good stuff. I'm glad you're all okay. Cool. Now they want the size of PSQ. All right, so PSQ is this angle over here. PSQ, it's that angle over there. Right. So any ideas as to how we would calculate that angle? Anyone get that already? Or got anything they want to? They want to share with us? Yes, you can do it that way, Cassandra. Anybody else? Cassandra's given a suggestion. You can do it like that. Yes, Cassandra. Or you could use exterior angle of triangle. Okay, so what Cassandra's talking about, everybody, I'm just going to move that over. And then what I'm going to do here is I'm just going to make this diagram a bit bigger just to hopefully make this a bit more obvious. Okay, so I'm going to get rid of all of those. And when they ask you to calculate the angle between two straight lines, often what they want you to do is use exterior angle of triangle. So here is the triangle. Or you could do what Cassandra was saying and work with vertically opposite angles and then angles on a straight line. But there's your triangle. Can you see that from S to P, this line has been extended, and that beta would be the exterior angle of the green triangle. This angle over here is also alpha because of vertically opposite angles. So if we add alpha to the angle we're looking for, we would get beta. Do we see that? Does that make sense to everyone? Okay, all right. So,
Oh no, that says please explain, ma'am. The rest says yes, 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 yes. It makes sense.
is everybody okay?
Except Kutwano.
Okay, so Kutwano, just listen to the explanation because I'm going to repeat myself again, okay? When they want you to calculate an angle between two straight lines, it's often from exterior angle of triangle. So the triangle I've highlighted in green, and if I add together alpha and this one that I'm trying to calculate, those would be the two opposite interior angles, which would add up to the exterior angle, which is beta, which you've already got. Okay, so, or actually, I'm saying you've already got, maybe I'm thinking about a previous question. Do we have beta? No, we've got PS, gradient. Okay, we don't, but that's fine. We can calculate it. Okay, so again, be careful if you are calculating angle alpha. All right, our gradient is positive. Alpha is an acute angle. Okay, so the gradient of QS we have. We got that in question 3.2. So I know that that was equal to 8. So therefore, working out alpha, we would go shift tan, put in the 8, and that would be equal to 82,87 degrees. Theoretically, I actually should not round off there. Okay. Then I want to work out beta. Now here, beta is the angle of inclination of a line with a negative gradient. Okay, so I'm going to have to do what we were talking about in the previous question. Okay, so where I would have to calculate the PAA or the reference angle if we wanted to do it that way. All right, so we have got tan beta, and the gradient of line PS we do not have, I don't think this is something we've calculated. So that would be 4 plus 2 over minus 1 minus 2. Okay, so tan beta would be equal to 6 over negative 3, which is negative 2. So I'm going to calculate my PAA because that's how I like to do it. And that gives me 63,43. And that means that beta is going to be 180 minus that 63,43. So beta is 116,54. Sorry, 57. Okay. Now I can say that angle PSQ plus alpha equals beta because of exterior angle of triangle. Therefore, PSQ is going to be equal to 116,57. And again, I should keep all my decimal places there. Minus 82,87. And we're getting 33,70. Okay, does that make sense to everybody? Okay. Oh, good. Okay, so that's something else that we see often in analytical geometry is this whole idea of calculating an angle between two straight lines. Brilliant. Okay, nice. Good job, everybody. How many marks was that out of 4? Okay, so here they've got to give us a mark for angle alpha, angle beta, for exterior angle of triangle, and then for our answer like so. Okay, now let's go and have a look at the next thing they want us to do. They want us to show that QS is the diameter of circle SQR. So let's go back and have a look at the question. Show that QS is the diameter of triangle SQR. Well, what does that mean? How do we show that a line is a diameter of a circle? So grade 11s, this is a sort of big test of your Euclidean geometry, your grade 11 circle geometry. Matrix, you also have to think back to grade 11 and think about how did we prove that a line was the diameter of a circle. Lebogang, you got your hand up?
Ma'am, can you please go back to the diagram?
With pleasure.
Ma'am, wouldn't you, if there was a circle around the parallelogram, wouldn't you use equal radii to prove that it's a diameter?
Okay, so it's not around the parallelogram. Okay, it's around SQR. So it's around this triangle over here. There can't be a circle drawn around a parallelogram because a parallelogram is not a cyclic quad. So parallelograms can't be cyclic because they're opposite, well, for lots of reasons, but probably the easiest way to explain it is because their opposite angles are equal. They're not supplementary. Okay, so it's through S, Q, and R. It's not through all 4 points. Ah, okay, so we don't have any radii. So Cassandra says there an angle is 90. So yes, Cassandra, that is correct. Which angle? What has to be 90? Any ideas? Oratila, you're right. Yes, it has to be angle R. It would have to be angle R. Okay. Now, I want to just draw something over here for you guys, just to explain this a little bit more. Okay. So I'm going to draw a circle, as good a circle as I can get, and we're going to draw a diameter. Okay. And a diameter is a chord that goes through the center of a circle, doesn't it? Okay, so if that point over there was the center of the circle, we would say that line AB is a diameter. If I now then take B to the circle, so if I join that line to the circle and I do the same thing from A to the circle, over there, I could call this point C. And if I told you that AB is, or this was given, that AB is a diameter, what would you conclude? What would that mean to you about angle C? If you were given AB as the diameter, what would you then conclude about C? Exactly. So you'd say, precisely, you'd say C equals 90, and your reason would be angle in a semicircle. Beautiful. Right. So what this question is asking you to do here is the reverse of this. We need to show that angle R in this case, like angle C, is 90, and therefore AB would be the diameter. Okay, so what they're asking us to work with here is converse angle in a semicircle. Does that ring some bells now? Okay, it is the converse of this theorem. Okay, we are working backwards. If we can show that R, and I know R does not look like it's 90, but if we can show that R is 90, then we have proved that QS is the diameter of the circle going through S and R and Q. Okay, so now again, this is a question where they're asking us to prove that an angle is 90. That's the same as asking us to prove that lines are perpendicular. So can you see it's the same question as this one, where it said, show that PS is perpendicular to PQ. But look how it's been asked in a completely different way. Right, so whoever would have thought that we're doing exactly the same thing and it's a completely different question, but it means the identical thing. All right, we have to prove that R is 90. Okay, so when we want to prove that an angle is 90, we're proving lines are perpendicular. That means showing that the product of the gradients is -1. Does that make sense to everybody? Ah, wonderful. I'm so glad, Cassandra. Brilliant. Oh, I'm so glad. I love it when you guys have light bulb moments. I really do. Yeah. So whoever would have thought, but that's what they mean. Okay, and again, you can see this question is pulling together our Euclidean geometry into our analytical geometry. Like the boys that I teach at school, I always say this to them all the time. Don't think about something that you learn like this is analytical, this is trig, this is Euclidean, this is functions. Everything's connected. All right. And here's a lovely example of how we can connect Euclidean geometry to analytical. Yeah, I forgot about those. Yes, Lebogang. We're going to be revising those when we do focus on Euclidean geometry. Okay, I'm going to spend a bit of time discussing stuff like that with you, how to prove that quads are cyclic, how to prove a line is a diameter, how to prove a line is a tangent. Okay, these things are important. They're difficult, but they are important that we're able to do this. Okay, so let's get that down. So we know now that when we understand the question that this really is a gradient question. So we need the gradient of SR. Remember, we know the coordinates at R now. We know that they are 6 and 0. So let's work out the gradient. Just move that out the way here. We need the gradient of SR. So let's work that out. So that would be 0 plus 2 over 6 minus 2. That would give us 2 over 4, which would be 1 over 2. Now we need the gradient of QR. Just going to scooch over just a little bit here. So the gradient of QR. And again, can you see it's useful for me to label what it is that I'm doing? So the people that are marking my work can see which line I'm calculating the gradient of. Okay, so that would be 6 minus 0 over 3 minus 6. And that would give us 6 over negative 3, which would be negative 2. Boom. Okay, exactly what we wanted. All right, so now we can say, therefore, can you see I'm setting it out in exactly the same way? Times negative 2 gives me negative 1. Therefore, the gradient of SR times the gradient of QR equals negative 1. Therefore, SR is perpendicular to QR. Therefore, angle SRQ equals 90. And now my final statement, therefore, SQ is the diameter of the circle they gave us. And my reason here is going to be converse angle in a semicircle. Okay. I should also like to point out at this point that this question comes from a grade 11 paper, okay, and not a grade 12 paper, in case you were wondering. Right, this is a grade 11 paper, this particular one. Okay, so we can see grade 11s. There are some pretty hectic things that they're expecting us to know and understand by the time we get to the end of grade 11. All right, so out of 4, mark there, mark there. There would have to be a mark on getting that, and then, so we have to state this and our reason together, because this is what proves it, and then our final mark would be for that, for writing SRQ as 90 and converse angle in a semicircle. Okay. All right, so now we're essentially down to our very last question. How much time have we got? Oh, we have got a little bit of time. That does help us. Okay, so let's go and have a look at the last thing that they wanted us to be able to do in this particular case. And there's quite a lot of reading here, although it's only out of 2 marks. So it says parallelogram PQRS undergoes a transformation. Okay, so then they're giving us a rule, a rule for translation. So K and M. So K would be how much we were moving it either to the left or to the right, and M is an implication that we're either moving it up or down. And they've told us that K and M are integers. Okay, determine the minimum value of K plus M such that the X and Y coordinates of the vertices of the image of PQRS are all greater than or equal to 0. Wow, what a mouthful. Okay, let's break that down. Okay, well, we all know what integers are. Okay, so that means that that bit is easy to understand. So they want us to add K and M together. So we've got to add the values or the numbers, our integers together, such that the X and Y coordinates of the vertices of the image of this are all greater than or equal to 0. So when they talk about the image of PQRS, that's the transformation that it is undergoing. And when they say the X and Y coordinates of the vertices are all greater than or equal to 0, it means that they all have to be positive. Right? So in other words, if we have a look at our vertices at the moment, okay, we have got a negative X over there, and we have got a negative 2 over here. So what they are implying by this weird question is that the translation that would have to take place here is that this parallelogram would need to be moved a minimum of 1 unit to the right, so that this -1 isn't a minus anymore, and a minimum of 2 units up, so that this -2 is not a -2 anymore. Does that make sense to everybody? And I'm sure it doesn't, because it's a crazy question. But that's what they're getting at. Oh, good, Lumelo. Okay, so they want all the coordinates to be positive numbers. That's what they're trying to say. Okay, all the X and Y coordinates at all the vertices need to be positive numbers. They're not allowed to be negatives. They've got to be, what does it say here? Let's just go back and have a look at it. Are greater than or equal to 0. Okay, so that all that long-winded gumph was simply that. Okay. So what that means is that we would, in terms of X, we would have to add, let's just set that out the right way. So in terms of X, it would have to be X plus 1 in order to move it to the right. In terms of Y, it would have to be, sorry, not X plus 2, it would have to be Y plus 2, and that would move the parallelogram up. Okay, so that means that K would be equal to 1, M would be equal to 2, and therefore K plus M would be 1 plus 2, which would give us 3. All right. Okay. Any questions before we go to the last one? Lebogang.
Ma'am, can you please scroll back to 3.6? I got kicked out by load shedding, ma'am.
That's all right. Where do you want me to go to?
3.6, please, ma'am.
3.6. Okay, I did that. Okay, so that was the purple.
Yes, ma'am.
Okay, it's this one in the middle of the screen.
Oh, thank you, ma'am. Let me just take a screenshot. Thank you, ma'am.
No problem. All right. I'm sure Lebohang's done now. And we can move on. Okay. I hope you guys are enjoying these sessions on a Saturday and that this is useful to you. Pleasure, Lebohang. What I'm going to do is continue with this question. Now, this question comes out of a matric paper. And I'm going to try and get through as much. Oh, good, Lesedi, I'm glad. Pleasure, Mesh, no problem. I hope we all feel like that. Okay, so this question comes out of a matric paper, so I wanted to sort of balance what we were doing today, show you some grade 11 questions, some grade 12 questions. And what we see with a lot of these things is that the first few questions are nice and easy. They're about gradient and midpoint and length of a line. And then after that, things start to get a little bit more complicated. All right, so now in this particular question, oh, good. Oh, I'm so glad. I'm so glad. In this particular question, you can see, we see the same sort of things. In 2.1, calculate the length. 2.2, the gradient. 2.3, the equation of a straight line. Question 2.4 is an x coordinate. Again, proving that lines are perpendicular. We've been through all of this. Calculating theta and angle of inclination. Look here at question 2.7. This is the reason I really wanted to do this question with you guys, is because now they ask us to calculate the area of a triangle. Okay, so again, it's all that usual stuff and then something that is a little bit more unusual. All right, so very quickly, because I really wanted to explain to you how we would do 2.7. In 2.1, we would get, let's just try and do this as fast as we can. See, and unfortunately, we always need what we've previously calculated going forward. Okay, so the length of BE, we would sub in our coordinates. And then -1 minus 0. And we should be getting root 17 as our answer. In 2.2, calculating the gradient of BE, we would end up with 0 plus 1. Okay, and here they've said it's a quadrilateral. So it's not a parallelogram. This is just a quadrilateral. So we've got to be careful here. Looks like a parallelogram, but we can't make any assumptions that it is unless they've asked us to prove that, which would be quite unusual at grade 11 or grade 12 level. Okay, so 0 plus 1, and then here we've got 1 plus 3. So this would give us 1/4. 2.3, the equation of a line parallel to BE passing through C. So I'm literally scooching right to the end here. We would need to sub in our coordinates at C, which are -2 and -5. Okay, so that means that C is going to be equal to -9/2. Okay, so the equation is this line, y equals 1/4x minus 9/2. That makes sense. Okay, then in question 2.4, where they asked us to show by calculation that x equals -4, can you see you've got AE equals EC? So again, you would need to do this by working backwards using midpoint formula. All right, so you would have x minus 2/2 equals -3. So x minus 2 equals -6. And that's why, whoopsie daisy here, x would be equal to -4. All right, 2.5. Again, it's a repetition showing that AC and BE are perpendicular to one another. We've got the gradient of BE, so we would just need to work out the gradient of AC, and which should be -4 if we've done it correctly. So remember here, that's -4. Can you see how each thing we calculate helps us with the next one? So we've got 3 plus 5 as our change in y, and then at the bottom -4 plus 2. So that gives us 8/2, which is -4. We were expecting that as an answer. So 1/4 times -4 is -1. See how repetitive this actually is. And then when you get to that point where it becomes repetitive, that's when you know that it's starting to become a little bit easier because you've seen these all before and you feel confident in how to tackle them. Okay, so BE perpendicular to AC, got that. Nearly there, angle of inclination. Again, can you see theta has to be an acute angle? We've got the gradient of AC. We know that it's -4. So in question 2.6, we've got tan, what angle? Theta equals -4. So our P, whoopsie, AA is equal to, oh, sorry, I'm rushing a bit here, but I just wanted to spend a couple of minutes talking about that last question, 96. So therefore, theta would be equal to 180 less that, which gives us, okay, and hopefully with everything that we've done today, everybody's following here and we're all good. All right, so now we can tackle this last monster question, calculating the area of triangle FBE. So let's just highlight this triangle for ourselves. And there it is. Okay, so how do we calculate the area of a triangle? Grade 11s and grade 12s. What are the two ways that you know how to do this? The grade 11s may not be as familiar with the second way as with the first, but it just sort of depends on what you've, there we go, Lucedi. So we could either use the area rule, quite right, Kutwano. So either the area rule or half base times perpendicular height. Okay. So both methods will work in this particular question. And I only wish that we just had a bit more time because, well, maybe I can try and show you both. Let's go with half base times height first of all, because that's probably the one that is the most familiar to us. All right. What we could do here is, because we have the coordinates at E, you know the distance from here to the x-axis. If I treat line FB as the base of the triangle, then this little orange line that I'm highlighting now, that would be the perpendicular height. Do we know the length of that line? Almost, Lumelo. That's the x-coordinate. The distance that point E is from the x-axis is not 3 units. It's 1 unit. There we go, Gugu. Okay, so the y-coordinate tells us how far a point is from the x-axis, and x-coordinate tells us how far a point is from the y-axis. That's it, Mesh. Okay, so that dark orange little line, this perpendicular height, it is 1 unit long. I need FB. So if I want to do it this way, I've got the perpendicular height, I need the length of FB. So FB is a horizontal line. I don't need to use distance formula, but I need to know the x-coordinate at F. Okay, and F is, so E is the midpoint, yes, of line AC, and AC cuts the x-axis at F. So I know that F is the x-intercept of line AC. So what I can do is I can get the equation of AC. I can make it make y equal to 0, get the x-coordinate at F, and then I can say that the x-coordinate at B minus the x-coordinate at F will give me the length of FB. All right. So what I want to do is I want the equation of AC. What else do I have? Do I have the, I have the gradient, don't I? I know what the gradient of AC is. I know that it's -4. So I can sub in any point. Oh, hang on a second. Didn't I work out the equation of AC somewhere already? What did I do in 2.3? Oh no, that was the line perpendicular, sorry, parallel to BE. Okay, so that wasn't it. Okay, that's not it. So I could say y equals -4x plus c, and then I can sub in a point. So if I sub in point C, C has the coordinates -2 and -5. That's it, Msomi. Everybody have a look. Msomi's already done it already. Quite right. That is indeed the equation of the line. So when you do this, you'd get C equals -13. So y equals -4x minus 13. So to work out the coordinate at F, it's an x-intercept, y is 0. So 4x equals -13. So x would be equal to -13 over 4. So now to work out the length of FB, at B, the coordinate was 1. At F, the coordinate is this horrible thing, which is -13 over 4. So the length of FB will be 1 minus -13 over 4, which would give me 17 over 4. And now I could say the area of triangle FBE equals half base times height. So half, the base, FB is 17 over 4. The height is 1. And if we put that into our calculators, we'd get 2,125 units squared. Okay, so that's if we did it by half base times height. Are there any questions? Did you manage to follow what I was doing there? I know I was rushing a little bit at the end, but I just wanted to be able to do this with you. I'd also like to talk about how we would use the area rule, but let's just see where we end up. Shantae, you got your hand up?
Ma'am, can you explain again the FB, the calculation for FB, please?
Yes, sure. So in other words, what I'm doing here, Shantae, is if you have got a horizontal line, and let's say the x-coordinate at this point over here is 7, and the x-coordinate at this point over here is -2. If you want, and then let's say that's A and that's B. If you want to know the length of AB, you can say the x to the right minus the x to the left. So that would give you 9 units. That's essentially what I'm doing. Does that make sense to you?
Yes, ma'am. Thank you.
Okay, so I'm saying 1 minus, so 1 is the x-coordinate at B minus the x-coordinate at F because it is a horizontal line. Any other questions about my method here? Yes, it is. It is Ongani. It is going to be sent. That's pleasure, Bongo and Corsi. So if you wanted to, just very quickly before we say goodbye to each other, if you wanted to, you could also use the area rule. Now, grade 11s, you may not be as familiar with the area rule as the grade 12s, but when you use the area rule, it is a side angle side situation. So if you wanted to use the area rule, you would need the length of FB as well. You'd need the length of EC, and then you'd also need to work out the size of angle alpha. All right, so any ideas? So you know how to work out the length of FB. You know how to work out the length of EB using distance formula. How would you get the size of alpha? Any ideas on how we would get alpha? And then I promise I'll leave you alone to enjoy the rest of your weekend.
Bye-bye, everybody. Bye-bye.
Lebogang. Sorry, I'm just doing
Maybe-
one last thing. Sorry, Yolanda. Sorry.
Okay, no, that's fine.
Ma'am,
Okay.
wouldn't you use is it the sine rule?
You don't need to use the sine rule in this case. What you can do here is if you extend this line up here, that would be alpha over there. It would be vertically opposite. Can you see that? You've got vertically opposite angles here. So there and there, you've got vertically opposite angles. Yeah, exactly, Nkla. So M equals tan alpha, precisely. You've got the gradient of BE. So tan alpha would be the gradient of BE, which was 1/4. And then you could work out how big alpha was. Okay, and then subbing into the area rule, you'd end up with area equal to half, and then you'd need to say FB times BE sine of whatever angle alpha is. Okay, and then you could do it that way too. Right, Nkla? You're welcome to ask, and then we'll say goodbye.
Ma'am,
Hi.
is it wrong if
What?
you just use m tan alpha because of it comes from a positive axis to the line, like without
Yeah, no,
noticing that it's an opposite angle?
yeah, no, it's absolutely fine. So line EB, once you have extended it through B, it would have it's still got a positive gradient, so it would be an acute angle. So there would be nothing wrong with that. So we could do it this way as well. Absolutely. Okay, I'm just
Okay.
sorry I ran out of time at the end and I didn't get to show you guys that, but hopefully you understand what I mean. And if you're feeling adventurous, you can always try and see if it works out that way. Okay, unfortunately, we need to say goodbye now.